Hello and welcome to the impact of human activity. My name is Laura Lewis. Let's start today's session. Click on to the next slide. Okay, so number one, understand the effect of human activities on the atmosphere, climate and ecosystems, and describe the different effects such as climate change and ecosystem disruption, and how to answer questions on human activity. So I'm sure you've all heard of different things. This one will be crossing over with geography a bit. Okay, let's start. So let's have a think. So we're going to talk about, I won't say what exactly we're talking about, give it away too much. Let's have a think about the Earth and the Moon for a moment. Okay, so you can all see the moon at night time, sometimes during the day. So why does the moon have craters that are formed millions of years ago or millions of years old, whilst the Earth, well, very few can be seen on Earth? Okay, so the key point here is the moon does not have an atmosphere or weather to change the surface. So we're going to look at the atmosphere to be clear here, first of all. So the footprints on the moon that are left by the people who visited the moon are still there. So the moon does not have any weather or an atmosphere. Okay, so that's quite interesting. That's why you've got craters. You have some craters on Earth, but nowhere near as many as the moon. The moon's covered in them, isn't it? Because they formed a long time ago. So some still form today. They formed millions of years ago, and they're still there because there's no weather to weather them away. Okay, let's have a look at our atmosphere. So before we could talk about climate change or change to the atmosphere, we need to see what the atmosphere really is. So it's quite simple in a way and complex in others. So the atmosphere is a layer of gas that surrounds the Earth. So that would be a definition of the atmosphere. A layer of gas that surrounds the Earth. Okay, it's split into layers. So you've got so the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. So for today, we're pretty much mostly interested in the troposphere, maybe a little bit the stratosphere. Okay, but all the weather occurs in all the planes that fly, normal planes, like holiday planes, fly in the troposphere. So that's as low as 10 kilometers. Some jets can fly into the troposphere, sorry, into the stratosphere, but not called a commercial airline would fly up that high. Okay, some people may have seen Jeff Bezos and Elon Musk launching their rockets. Talk about the Kármán line, which is shown there, which is some people say space begins, because the atmosphere gets thinner and thinner the further you go up. Okay, so where space begins is a bit of a contested point. That's what they were talking about there. It's labelled there. Okay, so what is the atmosphere made of? So I need to see what it's made of first. So 78% nitrogen, 21% oxygen, argon at 1%, and carbon dioxide, so that's the one we're talking about mostly today, is only actually 0.04% of the atmosphere. So it's quite a tiny percent of the whole atmosphere. Okay, so, but it actually makes a big difference. You have other trace gases like water vapor, less than 1%, but that does depend on where you are, because you probably know something called humidity, which is the amount of water vapor in the air. So don't worry about water vapor today. We're mainly looking at carbon dioxide. Okay, and obviously oxygen is important to breathe for us as well. Okay, oops, skipped one there. So the atmosphere is extremely important. Okay, it does two things really. So it keeps the Earth warm. So without the atmosphere, the Earth would freeze over. Okay, if the atmosphere is suddenly gone, other than us not being able to breathe, you'll just freeze. So it also gives us oxygen to breathe. So actually plants make the oxygen through photosynthesis by taking carbon dioxide out of the air, but obviously we can breathe that oxygen. So it would not exist without the atmosphere. So going back to the moon a little bit there, the moon does not have an atmosphere and life cannot exist there. So obviously if we went to the moon, we need a spacesuit to walk around the moon, and we need to take the oxygen with us in a backpack. So we've got the oxygen, like when you dive, so in a backpack or in a tank. Okay, so little checkpoint here. Oops, sorry. Little checkpoint here. Copy and complete. So I would pause the video here just to check what we've been learning so far. We're going into more complex things, and just a bit of a background knowledge check. Okay, so we've got the answers. So the Earth's atmosphere consists of many layers. all of the weather happens in the troposphere. The most abundant of common gas in the atmosphere is nitrogen. That's 78%. The oxygen that we need to breathe makes up 21% of the atmosphere. Carbon dioxide makes up only 0.04% of the atmosphere. The moon does not have an atmosphere, so no life is found at its surface. Other planets do have atmospheres, so there could be life. None's been found so far, but we'll just talk about the moon. None's been found there. Other planets do have atmospheres, but none's been found yet. So that's still up for investigation. Okay, let's talk about the greenhouse effect. Okay, so the greenhouse effect is actually a natural process. Okay, so without it, like I said, the Earth would freeze over. Hang on, let me just go back there. Sorry, I've changed the slide. So let's just look at the top diagram there. So the sun warms the Earth's surface. Let's read through. There's lots of words, but let's read through. The atmosphere absorbs and radiates some of the radiation from the Earth's surface. So the atmosphere absorbs some of it. Some of the heat the atmosphere absorbs and reflects some radiation back to space, and some of the Earth's surface emits radiation. Okay, so I've summarized it underneath. So when we talk about greenhouse gases, okay, these are gases, and we'll go into the next slide in a bit more detail. The greenhouse gases absorb thermal infrared radiation and radiate it back to the Earth, making it warmer. Examples of greenhouse gases are carbon dioxide, methane, and water vapor. So that's that carbon dioxide, that's the main one there. Methane and water vapor also play a bit of a part, but carbon dioxide is the main one. So the summary is the sun emits radiation of different wavelengths, including infrared, but we feel it on our skin as heat. We can't see it, we can feel it. Some animals can see it, like snakes can see it, but we can't see it. Some radiation is absorbed and reflected. Some radiation passes through the atmosphere and is reflected off the surface. Greenhouse gases in the atmosphere absorb some of this radiation and radiate some back to the Earth. The greenhouse effect is a natural phenomenon. Without any greenhouse gases, the Earth would freeze over completely. So this is a natural phenomenon. This is not caused by humans, but we're going to talk about that soon. Okay, so let's look a bit more about the greenhouse gases. So greenhouse gases in the atmosphere, again, carbon dioxide, methane, and water vapor, absorb energy from the sun and radiation that is reflected from the Earth's surface. The energy from the sun is transferred to the thermal energy store of the atmosphere. Okay, that means it heats up, the atmosphere heats up. The atmosphere then radiates this thermal energy back to the Earth, warming it up. So the greenhouse gases keep the Earth warm. Okay, so this is when we get into the human caused things. So although a certain amount of greenhouse gases are needed so the Earth does not freeze over, humans are adding carbon dioxide to the atmosphere. So more carbon dioxide in the atmosphere makes the greenhouse effect stronger, warming the Earth. This is known as global warming. I'll find out a bit later on that we've started to redefine that as climate change. Okay, but global warming is the act of warming up, and climate change is the effect. It's quite a subtle difference because sometimes they're used interchangeably, but the act of heating up the atmosphere is global warming, and climate change is the effect. So we'll see a bit about that later. So burning fossil fuels for electricity, transport, it means like petrol in cars, and industry, so factories and things, creates carbon dioxide. So you can see there, we've got electricity, okay, we burn fossil fuels, so coal, oil and gas, transportation, industry, agriculture, okay, so that creates it too. Commercial and means businesses, residential means houses. So your carbon dioxide 82%, that's why I said about it being the main one there. It's the main one that's created. So humans putting carbon dioxide into the atmosphere is warming up the Earth overall, but we're going into more detail, but it's warming overall. So this is a copy and complete here too. Okay, so again, pause the video and copy and complete. Okay, so the answer, some of the radiation from the sun is reflected by the atmosphere back into space. Some radiation passes through the atmosphere and is reflected off the surface. Greenhouse gases in the atmosphere absorb some of this radiation, increasing the energy stored in the atmosphere. Greenhouse gases emit the radiation back to Earth, creating a warming effect. The greenhouse gases are methane, carbon dioxide, and water vapor. Humans are adding carbon dioxide to the atmosphere by burning fossil fuels for electricity and transport. Okay, so this is a recap. So greenhouse gases include carbon dioxide, methane, and water vapor. We need to know that. Okay. And carbon dioxide is the greatest cause of climate change, as humans are putting a lot of carbon dioxide into the atmosphere. Okay, so we can see here as a graph of year on one axis, on the bottom axis, and global average air temperature. So in general, it's increasing. So it does dip, so let's go down, up, but in general, it's increasing. Okay, and the bottom graph shows the carbon dioxide concentrations to amount from 1960 until 2000. There is a relationship between the amount of carbon dioxide in the atmosphere and the temperature. So the red line goes up and down due to summer or winter. That's why it's sort of squiggly, but generally is going up. So as the carbon dioxide in the atmosphere goes up, humans are putting in, the temperature goes up. Okay, so the 10 hottest years on record globally, okay, so these are, since records began, they've all been in the last nearly 10 years. It was 10 years at the time of recording, 2019, been the last 20 years, okay, 10 hottest years on record globally. Waiting for the results from last year. It takes a while to count up all the things, but obviously most of them have been recently. Right, okay, so talking about weather and climate here. So that could be confused quite a lot. So weather is what happens on a short-term basis. So for example, it is raining now or it's snowy today. The climate is a long-term average of temperature and rainfall. So weather is short-term, like what's happening right now or that day. Climate is long-term average. So, for example, the climate of the North Pole will be cold and dry. It doesn't actually snow very much there. The climate of the Atacama Desert would be hot and dry. The UK has a temperate climate, which means moderate temperature and rainfall. Okay, so let's talk about the Earth's warming up, but it's actually causing climate change. So if the climate continues to change, the following may happen. Remember, even though on average the Earth is getting warmer, not all places will become hotter or drier. Some may be cooler or wetter. That's why we generally use the term climate change now. Okay, so concerning things, up to 30% of the wildlife on Earth may become extinct. So coral reefs may die. Okay, that's on the bottom picture of coral reef. That obviously supports lots of animals and things. Okay, fish, corals. Okay. Number 3, crops may fail, so things can't grow due to too much or not enough rainfall. So it's not always about too much or too little rainfall. It could be different places, can be different. And flooding may become more common. That's a big one to be concerned about, is about flooding. Okay. So copy and complete. So again, knowledge check. Go down to the answers. So weather is what happens on a short-term daily basis. If it is very cold and snowy today, that would be describing the weather. The long-term average of temperature and rainfall amounts would be the climate. For example, the climate of the Sahara Desert would be hot and dry. The average climate of the Antarctic would be very cold and dry. The 10 hottest years on record have all been recorded in the last 20 years. I updated for 2021 there. The temperature of the Earth has been increasing over time. Although all of the Earth, on average, is getting warmer, not all places will become hotter. Some places may become colder or wetter or drier. This is why we call the effects of global warming climate change. The climate change can lead to ice caps melting, animals becoming extinct, floods and droughts. So when you hear people talk about the sea level rising, it can be due to the ice caps melting. Okay, so make notes on anything in the video if you have learned. Have a look at this graph. Okay, we went through it a little bit quickly, but you can look through it carefully. It's a video, so you can just stop, okay, and pause, and you can write things down. Make sure that you know what the greenhouse gases are and the effect. So again, go back to here, and you can pause the video and write notes down and draw the diagrams. Okay, so thank you for listening today. Hope to see you in another class soon. Thank you and goodbye.